हेलो एवरीवन। आज हम लोग सीखेंगे कॉन्टिन्यूटी। सो कॉन्टिन्यूटी क्या है? अगर कोई ग्राफ है उसमें कोई ब्रेक नहीं है, राइट, और जंप नहीं है वहाँ पे। उस ग्राफ में कोई ब्रेक नहीं है या तो कोई जंप नहीं है, तो उसको हम लोग बोलेंगे कॉन्टिन्यूअस कर्व। ओके, सो हम लोग बोल सकते हैं कि लेटर से एक ग्राफ हम लोग ले लेते हैं। लेटर से वी हैव ए ग्राफ which looks like this. Let us say this is our graph and this is our y equals to fx curve. Okay, now fx is not defined at, if we say that here is a breakpoint, here is a breakpoint, then at point A, this is your x-axis, this is your y-axis. So we can see that fx is not defined at x equals to A. There is a hole in the curve y equals to fx, right? So fx is not continuous. Fx is not continuous at x equals to A, right? And we say that if we see that in the left hand side the height is L and in the right hand side of the hole the height is R, and this hole has the value f of A, that is this height is f of A. So from the graph it is seen that L equals to R, right? That is, we can say limit x tends to A minus f of x is equals to limit x tends to A plus f of x. Okay, so left hand limit and right hand limit are equal. So we can say, and we can say limit x tends to A f of x exists, right? So it disobeys our continuity, right? Thus continuity of f of x at x equals to A is disobeyed, right? So we can say continuity of fx at x equals to A is disobeyed if limit x tends to A f of x exists but f of x is not defined at x equals to A, right? So here limit x tends to A f of x is exists, right? Here we have seen that left hand limit and right hand limit are equal, but value of the function at that point is not defined, right? Now let us consider another scenario. Let us consider another scenario. Let us say now the graph looks like this. There is a hole and left hand limit and right hand limit are equal, and value of the function at x equals to a is, let us say, f of a here. Okay, here. Now let us say the value of the function at x equals to a is f of a, and this is your similarly y equals to f of x curve. Sorry. So from this graph also we can say that L equals to R, that is limit x tends to a minus f of x equals to limit x tends to a plus f of x. These are equal. So we can say so we can say limit x tends to a f of x exists, but we can see that there is a hole in the curve, right? So it is obvious that limiting value of x tends to a f of x is not equals to value of the function at that point, right? So f of x is discontinuous. F of x is discontinuous at x equals to a. So here the possibility is at x equals to a, if limit x tends to a f of x exists, but it is not equal to the value of the function f at x equals to a. Okay. Now let us consider another case. Let us now say our curve looks like this. Now this is our L and this is our R, and this is your y equals to f of x curve. And now the value of the function, is here, f of a. Okay, this is your a point. Now here we observe that L not equals to R, right? That is limit x tends to a plus limit x tends to a minus f of x is not equals to limit x tends to a plus f of x, right? So limit x tends to a f of x does not exist, right? Also f of x, sorry, also f of x is not continuous. Also f of x is not continuous at x equals to a, right? So thus we can say the continuity of f at x equals to a is also disobeyed, right? If limit x tends to a f of x does not exist, does not exist, right? And why this is happening? Because there is a jump, right? There is a jump of the value. There is a jump in the function f of x at x equals to a, right? So let us see another scenario. Let us say we have two curves which looks like this. This is your y equals to f of x curve, and let us say another curve is this. Let us say this is your y equals to f of x curve, and value of the function at x equals to a is f of a. Okay, so we can say in this curve we can say that fx is defined, fx is defined at x equals to a, because we have a value at x equals to a, right here. X equals to a, and limit x tends to a minus f of x is plus infinity, right? This is going to plus infinity. And in this graph we can say fx is defined at x equals to a, limit x tends to a minus, sorry, x tends to a minus f of x equals to plus infinity, and also we can say limit x tends to a plus f of x is plus infinity, right? So from these two curves we can conclude that the continuity of a function f is also disobeyed if either of the two limits, that is left hand limit, limit x tends to a minus f of x, and right hand limit, limit x tends to a plus f of x, both tend to plus infinity or minus infinity, and f of a is finite. Okay, so from all this discussion we can conclude that, right, we can conclude that a function fx can be continuous at a point x equals to a. So let me write it down. A function f of x can be continuous at a point x equals to a if and only if, right? I double F means if and only if, number one, f of a is defined, number two, limit x tends to a, f of x exists, and number three, limit x tends to a, f of x is equals to value of the function, right? These three things should be satisfied. So now let us say our graph is this. Here we have the value of the function at x equals to a is f of a, L equals to r, left hand limit equals to right hand limit, right? Here L equals to R. So this is the curve y equals to f of x, right? So we can say in this curve that f of x is continuous at x equals to a. So for continuity, left hand limit equals to right hand limit, that should be equals to value of the function at a point. So continuity at a point, this would be this thing, limit x tends to a, f of x equals to f of a. This implies this thing, this whole thing imply left hand limit equals to right hand limit, right? So limit x tends to a minus f of x should be equals to limit x tends to a plus f of x, and that should be equals to f of a. So for continuity, these three things should be equal, right? If any of one of them is not equal, then the function would be discontinuous. It may be left hand limit equals to value of the function, right hand limit equals to value of the function, left hand limit equals to right hand limit but not equals to value of the function. In all these cases, the limit will be, the function would be discontinuous. Okay, so a function is said to be left continuous or continuous from left at x equals to a if and only if left hand limit exists and left hand limit equals to f of a, and the function is called right continuous if right hand limit exists and right hand limit equals to f of a. Okay, so to be continuous, these three things should be equal. Okay, so I think now you have the idea what is continuity. Now moving forward to our next topic, algebra of continuity. Algebra of continuous function. Algebra of continuous function. So let us say let f and g be two real function at x equals to a. At x equals to a. So let alpha be a real number. Let alpha be a real number. So from the algebra of continuity, we can say f plus g is continuous at x equals to a. Okay, and this f function is continuous at x equals to a, and this g functions is continuous at x equals to a. Okay, this is two functions continuous at x equals to a. So their addition will be continuous. Number 2, their subtraction is continuous. Number 3, alpha is any scalar or real number. Alpha into f is continuous at x equals to a, right? Always at x equals to a, because we have taken the point to be x equals to a. Multiplication of the function is continuous. Inverse of the function is continuous, provided f of a should not be 0, because 1 by f of a is 0, it would be infinite, right? F by g is also continuous, provided g of a is not equals to 0. This is our algebra of continuity. Now, our next point, let f and g. These all things can be proved, but I don't think it is needed here because it will be wasting of time. You have to check the continuity as given in the question. So these things are comes into theorems. Okay, so you don't need the proofs here. Let f and g be real function, be real functions such that f of g is defined if g is continuous at x equals to a and f is sorry मेरा गला थोड़ा खराब है and f is continuous at g of a. Okay, then f of g of x, that is fog, is also continuous at x equals to a, right? Remember this. If f and g are two real functions such that f of g is defined if g is continuous at x equals to a and f is continuous at g of a, then f of g is also continuous at x equals to a. Now let us see the application of continuity, or let us check some continuity here. So our question number 1, test the continuity. Okay, all of the question will be test the continuity. F of x equals to mod of x by x if x not equals to 0 and it is 1 if x equals to 0. Okay, test continuity. So let us check. Let us see the answer. How to solve? Remember this. Here we have to find left hand limit and right hand limit. So our left hand limit at x equals to 0, right? The point is at x equals to 0. So left hand limit at x equals to 0 is defined as limit x tends to 0 minus f of x, that is equals to, always remember that is this is limit x tends to, you have to convert x tends to 0 minus or 0 plus into h tends to 0. So if you convert this into h tends to 0, then here function would change into f of a minus h. If this is left hand limit, then it should be a minus h. Okay, now a point is 0, right? So you can say limit h tends to 0 f of 0 minus h, that is limit h tends to 0 f of minus h, right? Now see what does it mean. X not equals to 0 means either x greater than 0 or x less than 0. So for both of the things we have to take this function. Okay, now what is left hand limit of the function? If x is less than 0, then mod of x would be minus f x, right? Right, or you can say you have to put minus h in place of x. So you can say limit h tends to 0 mod of minus h by minus h. right? So it would be limit h tends to 0 for mod of minus x. Mod of x is plus x if x greater than 0 and minus x if x less than 0. So if x is less than 0, then x mod of x should be minus x. So here already minus sign is there, and mod of h would be minus of mod of h, so it would be plus of h. So plus of h by minus of h, it would be h cancels out, it would be minus 1, right? Now let us check right hand limit at x equals to 0. So it would be limit x tends to 0 plus f of x. You have to convert it into h tends to 0. So limit h tends to 0, f of, here you have to write a plus h. What is a? A is 0. So limit h tends to 0, f of 0 plus h, and it would be limit h tends to 0, f of h. So if x is greater than 0, it would be plus x. That means here plus x by plus x, that is plus 1, right? So limit h tends to 0, in place of x you have to write now h. So this would be mod of plus h by h. It will be limit h tends to 0, h by h. So it would be 1. So here we can see left hand limit is not equals to right hand limit, right? So function is not continuous. So it is not continuous. Okay. I think ये समझ में आ गया होगा कैसे करना है. Now let's see question number 2. Show that the function f of x given by f of x equals to x sine of 1 by x when x not equals to 0 and 0 when x equals to 0 is continuous at x equals to 0. So let's see the solution. So let us first check left hand limit at x equals to 0. So it would be limit x tends to 0 minus f of x. Converting it into h, it would be limit h tends to 0, f of 0 minus h. So it would be limit h tends to 0, f of minus h. Now in the function when x not equals to 0, means when x is greater than 0 and when x is less than 0, you have to put this function, you have to take this function. Okay, now in place of x put minus h. So it would be minus h sine of 1 by minus h. Now see limit h tends to 0, sine of minus h is minus sin h. So minus minus it would be plus. So it would be h into sine of 1 by h. That is h is 0 and sine 1 by 0, that is infinity. So that means sine value, you know, whether it is infinity or not, sine value varies from plus 1 to minus 1. So it is a dangling function, right? So we can say it is an oscillating number. It is an oscillating number between -1 and 1. So it would be 0. Now let us check right hand limit at x equals to 0. It would be limit x tends to 0 plus f of x, that is limit h tends to 0 f of 0 plus h. It would be limit h tends to 0 f of h. So it would be limit h tends to 0 h sine of 1 by h, right? You have to take this function for x greater than 0 also. Now if you put 0 here, it will again result into same thing, 0 into an oscillating number, and oscillating number between -1 and +1. So 0 multiplied by a number is 0, and it is given that when x equals to 0, value of the function is 0, right? So f of 0 is 0. So you can say these three values are equal: left hand limit, right hand limit, and a value of the function at that point. So you can say limit x tends to 0 minus f of x is equals to limit x tends to 0 plus f of x is equals to value of the function at that point. So that means it is continuous at x equals to 0. This function is continuous at x equals to 0. Now let us see another question. Show that the function f of x given by f of x equals to sin of x by x plus cos of x when x not equals to 0, and it is 2 when x equals to 0, right? So let's check the continuity. So left hand limit at x equals to 0, that is limit x tends to 0 minus f of x. It should be limit h tends to 0 f of a minus h, 0 minus h. It would be limit h tends to 0 f of minus h, right? So for left hand limit and right hand limit, you have to take this function, right? So limit h tends to 0, you have to put in place of x minus h. So sin of minus h by minus h plus cos of minus h. So this is a algebraic function of limit, right? So you can say limit h tends to 0, sin of minus h is minus sin h, minus minus plus. So it would be sin of h by h plus limit h tends to 0, cos of minus h is cos h, cos of h. That is, we know from the limit chapter, limit x tends to 0, sin x by x is 1. So it is 1. And if you put h tends to 0, cos of 0 is 1. So the value is 2. Now check the right hand limit. So right hand limit at x equals to 0, it would be limit x tends to 0 plus f of x, that is limit h tends to 0 f of 0 plus h, that is limit h tends to 0 f of h. Now you have to take the same function again, limit h tends to 0 sin of h by h plus cos of h. Here again same concept, you have to break the function, limit h tends to 0 sin of h by h plus limit h tends to 0 cos of h. That is 1 and this is also 1, and it is given f of 0 is 2. So you can say left hand limit equals to right hand limit equals to value of the function, right? So it is continuous at x equals to 0, right? Let's see another question. Question number 4. Show that the function f of x given by f of x equals to e to the power 1 by x minus 1 by e to the power 1 by x plus 1 when x not equals to 0 and it is 0 when x equals to 0 is discontinuous. So let's see the solution. So here we have to check the continuity at x equals to 0, right? So left hand limit at x equals to 0 is limit x tends to 0 minus f of x, that is limit x tends to 0 minus, limit h tends to 0, limit h tends to 0 f of a minus h, that is limit h tends to 0 f of minus h. So you have to take this function, so it would be limit h tends to 0 a to the power minus 1 by h minus 1 by e to the power minus 1 by h plus 1, right? Now see, e to the power minus 1 by h is 1 by e to the power 1 by h. So limit h tends to 0, 1 by e to the power 1 by h minus 1 by 1 by e to the power 1 by h plus 1. Now see, e to the power 1 by 0, that is e to the power infinity. E to the power infinity is infinity, 1 by infinity is 0. So 1 by e to the power 1 by h is 0. So it would be 0 minus 1 by 0 plus 1, that is minus 1. Now let's check continuity. Right hand limit at x equals to 0. So it would be limit x tends to 0 minus 0 plus f of x. That should be limit h tends to 0 f of 0 plus h. That should be limit h tends to 0 f of plus h. That should be limit h tends to 0 e to the power 1 by h minus 1 by e to the power 1 by h plus 1, right? So we can say if you take minus common, right, or if you divide by e to the power 1 by h, it would be limit h tends to 0. If you divide numerator and denominator by e to the power 1 by h, e to the 1 by h, 1 by h will cancel out. This will be 1 minus, it would be 1 by e to the power 1 by h, right? It will be 1 by e to the power 1 by h by 1 plus 1 by e to the power 1 by h. Because now we have seen 1 by e to the power 1 by h is 0. So this would be 1 by 1. So 1 minus 0 by 1 plus 0, that is plus 1. That is, it can be clearly seen that left hand limit is not equals to right hand limit. So function is discontinuous, right? So let's see our next question. So this would be question number 5. Discuss the continuity of the function f of x at x equals to half, where f of x is equals to half minus x when 0 less than equals to x less than half, and it would be 1 when x equals to half, and it would be 3 by 2 minus x when half is less than x less than equals to 1. So here we can see that we have 2 points, right? X equals to half, we have to check the continuity at x equals to half, because here it is half, it is half, and it is half. So this is the catch point, you have to observe this. Okay, so let us see our left hand limit at x equals to half. Okay, so limit x tends to a minus, that is half minus f of x, that should be limit x. Now if we convert this into h tends to 0, limit h tends to 0, it would be f of a minus h, so it would be half minus of h. Okay, if it is half minus h, then we have to put this is less than half, right? So we have to take this function. So in place of x we have to put half minus h, so this would be limit h tends to 0, half of minus half minus h. So half minus half will cancel out, and plus h tends to 0, so it is 0. So now let us check right hand limit at x equals to half, that is limit x tends to half plus f of x. So limit h tends to 0, f of half plus h. So here the function is x is greater than half, half plus. So that means we have to take this function, right? So limit h tends to 0, in place of x we have to put half plus h. So 3 by 2 minus of half plus h. Okay, so it would be 3 by 2 minus half, that is 2 by 2, that is 1, and h is 0. So we can clearly see left hand limit is not equals to right hand limit. So it is discontinuous. This function is discontinuous at x equals to half. Okay, now see another question, which should be question number 6. Now let us say we have given one question. If the function f of x given by f of x equals to 3ax plus b, if x is greater than 1, it is 11. If x is 1, then it is 5ax minus 2b. If x is less than 1, is continuous at x equals to 1. Find the values of a and b. So here in the question it is given that the curve is continuous and you have to find out the value a and b. Right, so it is given that left hand limit equals to right hand limit equals to value of the function at x equals to a. Now here a point is 1, right? So let us say left hand limit at x equals to 1. So it would be limit x tends to 1 minus f of x. This should be limit, and what is the function at x tends to 1 minus? At x tends to 1 minus, the function is 5ax minus 2b, right? You can directly put the values here, or you can convert it into h tends to 0. So limit h tends to 0, f of 1 minus h. So it would be limit h tends to 0. In place of x, you have to put 1 minus h. So it would be 5a 1 minus h minus 2b. If you put h tends to 0, it would be 5a minus 2b. Okay. Now let's find out right hand limit at x equals to a. So limit x tends to 1 plus f of x. This should be limit h tends to 0, f of 1 plus h. And for 1 plus, you have to take this function, right? So limit h tends to 0. In place of x, you have to put 1 plus h. It would be 3a into 1 plus h plus b. So h tends to is 0. So it will be 3a plus b, right? And it is given that f of 1 is 11. Right? Here it is given f of 1 is 11. So according to the question, left hand limit is equals to right hand limit is equals to value of the function. So this implies 5a minus 2b is equals to 3a plus b is equals to 11. So from here we can establish two equations, that is 5a minus 2b is equals to 11 and 3a plus b is equals to 11. From these two equations we can apply simultaneous linear equation and we have to solve, and we will find out a comes up to be 3 and b comes up to be 2. Okay, that's how you have to solve this type of problem. Now let's see another question. Question number 7. Determine f of 0 so that the function f of x defined by f of x equals to 4 to the power x minus 1 whole cube by sine of x by 4 log of 1 plus x square by 3 becomes continuous at x equals to 0. Okay, let's see the solution. So in order to be continuous, we know that limit x tends to 0, f of x should be equals to value of the function, that is f of 0, right? Now let's find out this thing. This implies limit x tends to 0, f of x is this. So this is 4 to the power x minus 1 cube by sine of x by 4 into log of 1 plus x square by 3, right? Now we know limit x tends to 0, a to the power x minus 1 by x is log of a, and we know limit x tends to 0 log of 1 plus x log of 1 plus x by x is equals to 1, right? And the limit x tends to 0 sine of x by x is 1. Limit x tends to 0 sine of x by x is 1. Now let's solve in this format. So what we can do here, this is equals to f of 0, limit x tends to 0, 4 to the power x minus 1, because we have to take this in this format, 4 to the power x minus 1 by x whole cube. If we write in this format, we see that we have taken x cube extra, so we have to multiply it by x cube, so we can divide by x cube, right? So here we have in the denominator sine of x by 4, so we need here x by 4, right? So we have taken 4 extra, so we have to multiply by 4, and this log of 1 plus x by x. So this x means whatever is there in place of x, that should be in the denominator. Whatever is within the sign, that should be in the denominator. So here within the sign we have x by 4, so we need x by 4 in the denominator. Only then it will be 1, right? So we have another x square, right? Because we have multiplied by x cube and we have divided by x cube. So it would be, we have written 1x here, so another x square is left behind. So it would be log of 1 plus x square by 3 by x square by 3. We need x square by 3. So we have taken 3 extra, so we have to multiply it by 3. So limit, so we can write it in this format. Limit x tends to 0, 4 to the power x minus 1 by x whole cube by, we have 1 by 4 extra, and here we have 1 by 3 extra, that means 1 by 12. So 1 by 12 into limit sine of x by 4 limit x tends to 0 by x by 4 multiplied by limit x tends to 0 log of 1 plus x square by 3 by x square by 3. So here this term will give log of a, that is log of 4 to the power cube. This will give 1 and this will give 1. So by 1 by 12, so 12 will be in the upward. So this is equals to f of 0. So this is the value of f of 0. तो हम लोग सिर्फ यहाँ पे सीख नहीं रहे, कोशिश हम लोग का ये रहेगा कि ज़्यादा से ज़्यादा जो क्वेश्चन है उसको यहाँ पे रिवाइज किया जाए, ताकि तुम लोग का जो कॉन्फिडेंस है वो बढ़े, राइट। अगर ये तो हम लोग चेक कर रहे थे कि कोई इंटरवल में, अगर कोई पॉइंट में हम लोग कंटिन्यूटी चेक कर रहे हैं, अगर कोई इंटरवल में चेक करना है वो भी उसका जो तरीका है वो भी तुम्हारा सेम होगा, मतलब वो पूरा इंटरवल में वो कंटिन्यूस होगा। ओके, सो remember some point related to continuity. The first point is the composition of two continuous functions is a continuous function. Okay, that means GOF and FOG, composition. These things are known as composition of function, right? So FOG and GOF are continuous. Next point, if f is continuous on its domain D, then mod of f is also continuous on domain D. Okay, if f is continuous, then mod of f will also be continuous. Next point, a constant function is everywhere continuous. See, this is a continuous function, right? Constant function, that will be continuous. Next point, the identity function is everywhere continuous. Okay, next point, a polynomial function is everywhere continuous. Polynomial function, that is x square plus 2x or 3x square plus 4x plus 4, right? This type of polynomial function is always continuous. Okay, now next point, every rational function is continuous at every point in its domain. Okay. Next point. The modulus function is everywhere continuous. Is everywhere continuous. Next point. The exponential function, let us say a to the power x, where a is greater than 0, is everywhere continuous. Okay. So e to the power x is a exponential function, right? So e to the power x is everywhere continuous. Next point. The logarithmic function is continuous is continuous in its domain. Okay. Next point. Sine, cosine, tangent, okay, sec, cosec, all of them are continuous. But sine function, sine and cosine function is everywhere continuous. But tan, cot, cosec, all these functions are continuous in its domain, are continuous in its domain. Okay. And remember, f of x sine inverse x is continuous on -1 to 1. So, so not only this, every inverse trigonometric function are continuous in their respective domain. So let me write it here. Every inverse trigonometric function every inverse trigonometric functions are continuous in their respective domain. Okay. Now let's see some questions. So that your concept will be crystal clear. So let's see. This would be our question number 8. Okay. Let's say if f of x equals to 1, if x is less than or equals to 3, it is ax plus b. If 3 less than x less than 5, it is 7. If 5 is less than or equals to x, determine the values of a and b so that if x is continuous. So let's see the solution of this. So here we can see that there are two breakage points. One is at 3 and one is at 5. So we can solve for, we can check the continuity at 2 points, at x equals to 3 and x equals to 5. So let's check at x equals to 3. So what would be left hand limit? It would be limit x tends to 3 minus f of x. That is, it is given that it is 1, right? F of x is 1. So it will be 1. So what would be right hand limit? It would be limit x tends to 3 plus f of x. So 3 plus, that means we have to take this function. Limit x tends to 3 plus ax plus b. Okay. So 3 plus means you have to take the value, or you can convert it into h tends to 0. Remember this method, just I have told you, because this finding limit in this method is very easy. Limit h tends to 0, f of a plus h. So that means in place of a is 3. So that means in place of x we have to put 3 plus h. So a into 3 plus h plus b. So h tends to 0. So that means this is 3a plus b. Okay. Now it is given that if x is continuous, that means left hand limit is equals to right hand limit. So we can say 3a plus b is equals to 1. Right? We got one equation. And let us check continuity at x equals to 5. So left hand limit would be limit x tends to 5 minus. So for 5 minus you have to take this function f of x. So this would be limit h tends to 0, f of 5 minus h. That means in place of x you have to put 5 minus h. So limit h tends to 0, a into 5 minus h plus b. If you put h tends to 0, it would be 5a plus b. Right? And if you check right hand limit, it will be limit x tends to 5 plus f of x. So it would be limit h tends to 0, f of 5 plus h. And this would be limit h tends to 0 in 5 plus. That means you have to take this. This is 7, right? It should be 7. And it is given that the function is continuous. That means 5a plus b is 7. So here it is your number 1 equation. It is your number 2 equation. solve these two equation, we will get 5a plus b. We will get a equals to 3 and b equals to -8, right? So now I think that जो तुम लोग लिमिट का जो सम है वो सम तुम लोग बहुत आसानी से कर पाओगे, और खुद से थोड़ा प्रैक्टिस भी कर लो। ऐसा नहीं है कि बस एक क्वेश्चन करके चला जाना है, थोड़ा प्रैक्टिस खुद से कर लो। यू विल सी दैट ये चैप्टर जो है एटलीस्ट फॉर बोर्ड लेवल ये बहुत ही आसान है, ठीक है। तो इस वीडियो के लिए हम लोग 500 लाइक्स का टारगेट करते हैं। अगर ये मिल जाएगा तो जेई और जेई एडवांस का जो जो भी एक्स्ट्रा कुछ रहेगा, क्वेश्चन रहेगा, प्रीवियस ईयर रहेगा, वो हम लोग चैनल में अपलोड करेंगे। सब लोग शेयर कीजिए, लाइक कीजिए और सब्सक्राइब कीजिए। थैंक यू, हैव ए गुड डे।